Okay, so we're recording. So we're going to go over the concept of correlation and regression model, and hopefully hit some of the things. If you have some questions, let me know and we'll go over it. The first thing I want to go over is the correlation and scatter plot, and I'm going to put my screen in half here so that I can put StatCrunch in on the other side. Because I think it's very valuable to look at both of it at the same time. So we'll do this and this, so we have both screens up. So hopefully you can see both screens. So for the correlation and scatter plot, for correlation it really doesn't matter which is X and which is Y, because the correlation coefficient is going to be the same either way, the number that you calculate, the statistic that you calculate. But when you get to trying to do a regression model on it and do a explanatory variable and a response, residual plots, residuals are what happens when you take you plug in the value for X that you have into the equation and you get a Y hat. So you have a Y hat, this is the Y, and then you have the Y hat. So for example, I could in this one, let me see if I could do this. Let's see, if I go to data, compute, expression, and I'll build an expression, and I'm taking, ooh boy, I need to take my formula. Where's my formula? Let me go back up here. Okay, so I need my expression, let's see, my expression is going to be, I'll add 4 values, columns for the list. I'm going to put in a negative, where's negative? Negative 0.00832 times weight and plus 47.54 and okay, and compute. There's this, okay, if you will, is your Y hat values for those exact. So the residuals are the difference between these, between the actual and by the formula. So if you want to actually do the calculations, you can do that. Okay, and then you plot those. So then you plot the residuals. Okay, and the residuals then would be, I'm not sure, I forgot whether it's Y hat minus Y or Y minus Y hat. I think it's Y. Wait a minute, let me just double check so that I don't state it wrong. The residuals, residuals. Did I do my calculations that I showed it? Oh, back in here. I thought I did the calc. Ah, yeah, here we go. So it's Y minus Y hat. That's the residuals. Okay? So the residuals that you're going to actually plot, if I go back here to data, compute, expression, is going to be build. It's going to be Y which is the miles per gallon, minus the y hat, what did I do wrong? Miles per gallon minus, oh, I forgot to add it. Okay. There we go. Those are the residuals that are getting plotted. Okay. Now, you can plot those automatically. You don't need to go through all that process. But if they ask for the residuals, that a list of them, that's them. Okay. Now, you can plot the residuals. And here, if I go back to options, edit, okay, under graphs, there's a choice down here, residuals versus the X value. And that's what you plot. And so if I come over here, there's my residuals. Here's my zero line, okay, that you would have, and here's the residuals for this particular problem. Does that help a little bit? So if they ask you to choose which graph is the residual plot, that's how you can plot it. And you don't have to go through, you don't have to get this and plot it against weight. You just plot it, because here's the weights, and you plot these against the zero here. Okay? So it automatically does it without you going through all these steps. Now, the residual plots, the thing you want to remember about what's the purpose of this? Well, it tells you whether there's a pattern, a discernible pattern that may not be linear. So you're actually looking for these dots to be really sort of helter-skelter, because that means that there's enough of a variation in the residuals, plus and minus, from the original graph, okay, or original equation, that they're equally balanced out. And so therefore we can, it's a pretty good check that it's linear. If you have something like this one, that's more of a parabola shape. That's going to be a quadratic equation. That's not going to be a linear equation. Okay? You want something more like this, where the explanatory variables here and the residuals are here, and they're just sort of scattered. Now, if you see some numbers like out here, okay, you see these here? They're way the heck out from everything else. That would be outliers. Would be another flag that would get sent up as to whether this is a linear regression or not, because those outliers can pull and make our correlation look different from what it really is. And so if there's outliers in the data, then there's also outliers in the residuals. And that tells you need to look deeper into what's going on here, because you're not done. Okay? So those are the things that you're looking for. A discernible pattern. If there is one, it may not be linear. And if there's residuals in the outliers, they're going to fall far from the rest, and that's going to be another red flag that's going to go up and say, I better look at this more cautiously. Okay? So that pretty much covers this week and what we did for homework. So were there any questions left on the homework that I haven't answered here? Okay, so the rest is going to be notes for you, okay, because I'm going to go into next week as well, okay, and next week just continues on, but it's chapter 14, but the concepts are the same. You start with the same point. Oh. I don't know how to fix that. I see that. I I don't know. If you're having trouble with something like that and you're getting a wrong answer, why don't you let me know which problem it is, okay? And I'll see to it that you get credit for it. Oh, okay. Well, then you have some support. That's great. That's fantastic. That's absolutely fantastic. It will put her in good stead as she goes on through school. So I'm going to start with next week, okay? So this may seem a little bit way out, but once you get into it next week, it'll make a lot more sense, and you can come back to this video. Just come back to the recording. I don't know if I have anything in here that tells me what time frame we are, but we're at, well, we started at exactly 1 o'clock, so it's 35 minutes in. So you can always rush through the video and get to that point, and then start this over again if you need to, okay? So I'm going to go back to my some simple data for the purposes of this, because, let's see, can I edit? I want cut. Just I'll delete. Make this one X, this one Y, this one bar 2, and I'll just make this one bar 3, just for argument's sake. And I'm going to copy these numbers in here for our example. Okay? So, again, when you start this, the first thing you're going to want to do in Chapter 14 is go right away to Stats, Regression, Simple Regression, and you're going to want to plot the X and the Y, and basically that's what you need, okay? And we can always come back. Remember, again, fitted line plot will give you what you need, and residuals, I'm going to do these all at once so that I have them. Residuals, fitted line plot, I'm going to hold my shift key down and get, oops, I don't want both of them, all of them, I just want those two, so I'll hold my control key down. And residuals. I think I got them all. Let's see. Nope, I didn't get the fitted line. Oh, it's only giving me the one. Oh, there they are. Okay. And compute. Okay. So this should look like this. Okay, perfect. So my Y hat that they talk about, and in Chapter 14 they start using other symbols. So they use B1 for the slope of the equation and B0 for the y-intercept. And the reason is because in standard quadratic equation form, the constant in the equation is always B0, and they're going to use the same symbol. So B1 is the coefficient of the x term, B2 will be the coefficient of the x squared term, B3 would be the coefficient of the x cubed term, and so on. Okay, so in this particular example, and again, I remind you that when you're doing the example, that what it does in StatCrunch is not the same as the way you're going to write it. So in this example, y hat is 2.2674x minus 3.24. And these signs are really tiny in this, so be very careful about, don't lose those, especially on the final exam. Okay, it's very easy to miss those, so be careful of those. Now, our general terms, which is, so these are, y hat is all about the sample. Okay, so remember how mu, that symbol, was represented by x bar in the sample? So mu is the mean of the population, and x bar was the mean of the sample. And sigma was the standard deviation of the population, and S is the standard deviation of the sample. Well, here we have the coefficient of the y-intercept, and beta 0 is the y-intercept of the population, the regression line of the population. And in the same way, B1 is the slope of this line, and beta 1 is the slope of the regression line for the population. Okay? They are assumed, we assume them to be equal. And so B0 is negative 3.24, I think it was 444 when I put it out all the way, and B1 is 2.265. Now the most important one is this one. Okay, and I'm going to highlight it in red. And the reason that's the most important one is because the slope tells you, as we learned from before, the relationship between the x and the y variable. Like so with the weight of the car, okay, that slope tells you as you change 1 unit in the weight of the car, you change the miles per gallon by this amount, B1 amount. So it's the slope that becomes the really important part. And as we learned with the weight of the car, the y-intercept is sometimes important, sometimes not. Depends on the problem. Okay? So all the things that are going to take place in 14 are going to all be based on the slope, which is B1. Okay? Questions? So when this gives you y equals, they're making the assumption this is the equation of the population from which this came. Yeah, the beta symbol is for the population, just like the mu symbol is for the population mean. The beta symbols are the symbols for the y-intercept and the slope of the equation for the population. Okay? So, a couple more terms that come up in chapter 14. Okay? SE, it's the estimate of the error of the standard deviation. It's the standard error. And it is this number here. Okay? And I found that a lot of times, especially in chapter 14, people, not only did they not totally understand the variables, but they didn't have a clue as to which one of these numbers it was. So that's why I'm calling this to your attention. So it says in StatCrunch, the estimate error of the standard deviation, that's your S sub E. Okay? Your S sub B1, okay, which is the standard error of the slope, is this number here. That's the standard error of the slope. Okay. So what do they do with all this? Well, they do a hypothesis test. Summary stats. What summary stats? Standard error. Oh, yes, yes. But we're talking about the standard, well, it's different. The standard error from that is the, yes, standard error columns, exactly. That standard error is the standard error of the standard deviation of that sample, set of samples, data. So you find the standard deviation of the data, and then you divide it by the square root of n, and that is the standard error that you're talking about. So this standard error is a little bit more complex because it's based on the it's a standard error of y, which is if you calculate all the possible, you calculate the possible y hats, and you get the y is the mean, and then you calculate all of these, and then you get and you have a different mean for each one of the samples, or each one of the rows, and then you have to have a standard deviation, and this standard error, you see where this is coming from? It's getting a little bit more complicated. Okay, so that's why we use the technology, because if you look in the formulas in the textbook, they really can get pretty confusing. Okay, so this is my standard error estimate of the error of standard deviation. So what you're having is that, and you'll see this in graphs where they'll show you an equation of a line, and then they'll show you various possible different equations of lines, one standard deviation away from it, two standard deviations away from it. That's what we're getting into there. Okay, so and then the standard error of the slope, which is based on the slope of the line, is this number here. Oh, okay. So the next piece then is to do a hypothesis test. And it says assuming the residuals are normally distributed, so your HO is beta 1 is 0. Okay, because we're talking residuals now, versus H1, which is B1 is not equal to 0, and alpha find the p-value. Well, guess what? There's the p-value for slope. And therefore, you look at that, you compare it with 0.05, and you say, we reject the null hypothesis, therefore there's sufficient evidence at the 0.05 level of significance to conclude that a linear relationship exists between x and y. And once we've done that, then we've done the residual plot and all this other stuff, we can look at the graph itself, we can look at the residual plot, it looks pretty spread out here, and we're in pretty good shape. So we make the conclusion that we can use this equation to do our predictions. Again, if you look, we've got 3 to 8. So you're not going to put any values for x in other than maybe a 6 or something like that to test out anywhere from 3 to 8. You do not want to test out a value of 10 for x or a value for 1 or 2 for x, because then you're not in the realm of support anymore. And that's basically going to be 14. There's a couple more pieces to it, but that's basically what you're getting into. Question 5.5. I'm not, for that example. Yes, again, it depends on, I see what you're saying. Yes, you could use any of the fractional parts in between, assuming that these are continuous variables. Again, it depends on the topic. You know, this is where we step out of statistics and back into the real world. Any other questions? Okay, then we'll conclude. Thank you for attending. Thank you for being my sounding board. I really appreciate it. And I will post this video for everyone, and you can, like I said, if you want to look at this last piece, if you need some more help with it, don't hesitate to let me know. We can get together. We can always meet in this venue as well, and actually I can give you, I should have given you speaking permission even this time because there's only the two of us in here, but then we can just talk as well. Have a great weekend.